In this question, we have a double slit setup. So we are given some parameters of the whole setup. We are told that when one of the slit is covered, a single slit diffraction pattern is observed, which is obvious. Okay. So what is the width of this central bright band of the diffraction pattern? So let's go through the setup first. Okay, the parameters. We have the slit separation, that is 0.12 millimeter. So this is the 0.12 mm. We also have the slit width. Okay, so this is equals to 0.025 millimeter. So in this question, right, we are figuring out we're trying to figure out what is the width of the central bright band. Okay, so and that arises because we cover up one of the slit. So we actually do not need to use the slit separation. We only need to use the slit width. So slit separation is actually a redundant info. Once we know that, we can proceed, right, to figure out what is the angular position of the first order minima, okay, of the diffraction pattern. So we know the equation is as such. And we also can see, right, from the overall setup, okay, the first order minima, right, is found at the location, right, x from the center of the whole pattern. Therefore, right, you can also write tangent theta equals to x over L, okay, thereby, right, defining x in terms of tangent theta and L. So that's the second equation we can write. Noting, right, that in this case, theta is actually really small. How do we know that? We can just gauge, right, by the sine theta or the tangent theta. So we see, right, from the sine theta, lambda upon a, lambda is 10 to the power of minus 7, a is 10 to the power of minus 5. So the ratio, right, of lambda is to a is around 10 to the power of minus 2. So that's really, really small, okay? So with that, right, we can employ the small angle approximation, whereby sine theta is equals to tangent theta. That way, right, we can combine these two equations, okay? So we know on one hand, the angular position is sine theta equals to lambda over a. On the other hand, on the setup scale, you know that tangent theta is x over L. So what we want in the end is to find what is the 2x, which is the width of the central bright band. So we combine them in the equation, okay, and solve for 2x. Turns out 2x is equals to 2 cm. Note that, right, in this equation, I did not convert L into meter. I keep it as cm, okay, because, right, I note that here is actually a ratio. And in the end, right, all my expected answers are in cm, so I didn't bother to convert. So I'm expecting a ratio of 52 cm. So that in turn is a distance in cm units, okay.